Hello, my dear children of class 11 science. Today, again, I welcome all of you through this mode of teaching that is called YouTube mode. And in today's class, we start the new unit. This is the second last unit as per class 11 syllabus, unit number 9. And the name of the unit is called Behavior of Perfect Gas and Kinetic Theory of Gases. So this is the unit with the chapter. So only one chapter under this unit, and the chapter is also same, that is behavior of perfect gas and kinetic theory of gases. Now this concept is even related to chemistry also, okay, because when we talk about the gases, okay, and when we talk about the kinetic theory of gases, we talk in details about the motion of the gases, the properties of gases. But before we come to the kinetic theory of gases, we'll try to understand about the perfect gas. Now, perfect gas is also called ideal gas, or we also call as imaginary gas. Okay. Now, why we are considering a perfect or ideal gas is because a gas is a real gas also. There is a real gas also. But there is a main difference between real gas and what? An ideal gas or perfect gas. Okay. Now, as you know, as I know that you learn Boyle's law, Charles' law. Okay, these are the law you learn in class 9, gas equation. So whatever laws you learn in class 9, okay, this law is actually valid under the consideration of what? A gas called ideal gas or perfect gas. Okay. Now there is a main difference between ideal gas and a real gas. But let me just come back first to the concept of ideal gas or perfect gas. So let's start this chapter with the concept. Start with the concept of what? Ideal, also known as perfect gas. There is another name for ideal gas, also known as perfect gas. Now, laws like Boyle's law, Charles' law can be is easily applicable for the gases, but for not for all the condition. But for not the what? All the condition. Okay. Now, especially when we define Boyle's law, Charles' law, and gas law, these are the laws which is actually gives a relation between the pressure of the gas, the volume of the gas, and the temperature of the gas. Okay. Now, in actual practice, it is observed that the gases do not obey strictly the Boyle's law, Charles' law, and even the law of the pressure. There is a law of pressure also. Okay, in all the condition of temperature and pressure. So the gases which does not strictly obey Boyle's law, Charles' law, and law of pressure under all the condition of temperature, pressure, then this type of gases are usually called as what? Real gas. They are called what gas? Real gas. Which means, to tell you about the real gas are those gases, okay, which obey. It doesn't mean that they doesn't obey the laws. They obey Boyle's law, Charles' law, and the law of pressure. Okay, under a very low pressure. See, under the condition of very low pressure and very high temperature. Okay, but not at all the condition of temperature and pressure. Not all the condition of temperature and pressure. This means they obey this particular law only approximately, and the deviation from these laws are different from different gases. Different what? Gases. So we can imagine a gas, okay, we can imagine a gas which can obey the Boyle's law, Charles' law, and the gas equation, also called the law of pressure, okay, on all the condition of temperature and pressure. Such imaginary gas, okay, such imaginary gas which follow Boyle's law, Charles' law, and gas equation or law of pressure under all conditions of temperature and pressure is usually called as perfect gas, also known as what? Ideal gas. So we can simply just write the statement: ideal gas is an what? Imaginary gas. It's not a real gas, as I said. It is an imaginary what? Gas. Okay, which follow, or also called obey, which follow Boyle's law, Charles' law, and even the law of pressure. The law of what? Pressure under all condition under all condition of temperature and pressure, under all condition of temperature and pressure. Okay, and such gases are usually called as what? Imaginary gases are called perfect gas, also called what? Ideal gas. Now these gases, this particular gas has certain properties. That means if we imagine such type of gas, then definitely this gas must have certain property. So we just try to understand the properties of the gases. The properties of what? The gases. But what gases? The ideal gas. See, we are talking about the ideal gas. Now, when we talk of the property of ideal gas, there are certain important property that we need to keep in mind. So it is considered that, it is imagined that these gases are such gases whose molecules are infinitely small, very, very small. So one of the first property is the molecules. The molecules are infinitesimally, I am using the word, children, infinitesimally. Infinitesimally means very, very small, which tends to 0 but not equals to 0. The molecules are also very infinitely small. Very, very small in size of the molecules, okay, which tends to 0 but not equals to 0. So one of the first property of ideal gas is the ideal gases molecules are infinitely small. This is number one. We have number two. And number two is simply that these gases, again I write it down, these gases, okay, obeys what? All the laws. Now all the laws means like Boyle's law, it comes under Boyle's law, Charles' law also, the law of pressure, okay, the gas equation, okay, all the laws, which means Boyle's law, let me just add Boyle's law, Charles' law, okay, a gas equation, even we have law of pressure, law of what? Pressure, okay, under all the conditions. So this is important, under all the conditions of temperature and pressure. Temperature and what? Pressure. And such gases are nothing but the what gases? Ideal gases. So this is number two property. Okay. Whereas as I said already, real gases and in actual practice they are the gases which actually does not follow Boyle's law, Charles' law and law of pressure. If they obey these laws, they obey only approximately but under the condition like a very, very low pressure and very high temperature. Whereas if you imagine the gas which obey all this law under all the condition of temperature and pressure, even at low temperature or low pressure, okay, then such gases are called ideal gases. Okay, so this is number two property of ideal gas. Now we have number three property. Now number three property is there is no force of attraction between its molecules. So we consider that there is no force of attraction. There is no force of attraction between the what? Molecules. There is no force of attraction between the molecules. That means we have already considered that the molecules are very, very small in size, and even these molecules are very far away from each other, so that there is no force of attraction exerted between the molecules. Whereas when you take real gases, molecules are separated away from each other, but the attraction, very negligible force of attraction exerted between the molecules. But in case of ideal gas, we assume that attraction is almost zero. We consider that means the molecules move freely. That means there is no force of attraction exerted between the molecules. So this is also one of the property of ideal gas. So with this reason, I can even add one more point with this property is that these gases, okay, cannot be converted. These gases cannot be what? Converted into liquid, cannot be converted into liquid or solid state. These gases cannot be converted into liquid or what state? Solid state. Now as I said, why it will not convert into liquid or solid state? Because the force of attraction is necessary between the molecules in the liquid or what state? Solid state. Whereas the real gases, can be converted into what? Can be converted into liquid state or gas state. Whereas ideal gases are such gases which cannot be converted into what? Liquid or what state? Solid state, because of no force of attraction between the molecules. So this is also one of the property of ideal gas. But children, this particular chapter is completely based on the ideal gas. Okay, completely based on the what gas? Ideal gas. Okay. Now we discuss the equation related to ideal gas, that is called ideal gas equation. Okay. With that, even we learn in detail about the theory of gases, that is called kinetic theory of gases. Okay. And the laws are also there. That means Boyle's law, Charles law are there, and all these laws are actually for the what gases? Ideal gases. Okay. But in actual practice, as I said, the gases which are difficult to liquefy, such as like oxygen gas, nitrogen, hydrogen, these are all the gases, and helium gases are considered to be as perfect gas. They are called what gas? Perfect gas. So which means perfect gas or ideal gases are those gases which are difficult to liquefy, means we cannot liquefy. Such gases are called ideal gas. So children, I have just given a concept of what? Ideal gas. Okay. Now we go to the next topic, that is called equation of state for an ideal gas, and we also call as ideal gas equation, and that you learn in the next YouTube video.